Okay, we're going to start right on time here. Thanks everybody for coming. This is pretty cool. I know Bruce Schneier is speaking just next door, so I almost didn't show up either. So thank you for being here. I appreciate it. All right, well, hey, a little bit about me. My name's John Yo. I'm head of research and development at a company called CSA Cloud Security Alliance. Anybody heard of it? Maybe? Oh, nice, excellent. So we research a lot of different technologies. Cloud's the obvious one. We generate best practices. We turn those into standards, into influence government policies, and we do this through a whole crowdsourcing exercise. So a lot of what I talk about will be shared perspectives from that group, but at the same time, according to this, all opinions are my own and my own only. But hey, if CSA doesn't agree with what I say, that's okay, right? We're all allowed to have different opinions. That's how we get through life. So, I'm okay with that. All right, everybody go back with me a little bit. We're going to go back in time, not that far, but we're just going to go back to around 2010, 2011, when I think a lot of these headlines were pretty familiar that everybody saw. Cloud was this new disruptive technology on the block. The promises were to change just about everything, right? The wave of the future, revolutionizing business. What else can you not do with cloud? This is a real article, Cloud Will Cure Cancer, and I think the idea behind it was, right, we were able to actually put a lot of good data into one large data set. We had access to it, we had analytics to it, so it was more about how can we get patients' symptoms, their backgrounds, their diseases, and can we convert that into some sort of improved therapies and things like that. So I think that was a good thing. In fact, that's one of my the first initiatives I ever had with cloud was actually doing such a thing, health information exchange from patients to researchers. So it was kind of one of those things. And if you look at the top there, there's no such thing as the cloud. It's just somebody else's computer. Who has a bumper sticker? I did. I had a t-shirt. So that was just a thing. And I think as cloud evolved, it's not just a computer. We saw a lot of capabilities like analytics and different capabilities that were brought on through cloud's very first entrance into our lives about 15 years ago. And so just to get a little baseline, that's what we saw with cloud about 15 years ago. And it really became this evolution of what cloud was. And if you explore with me a little bit what we're seeing here too, we saw a range of technologies that really came out of cloud or maybe were enabled because of cloud. So blockchain definitely had its moment in time, and I think it's still a thing. But without cloud capabilities, we didn't have a chance to put large blockchains up and make them available to everybody. Even the blockchain transactions themselves, if you look at what's happening with cryptocurrencies and crypto mining, a lot of this happens because cloud was available as a resource for us. IoT was another extension of the endpoint. As our networks got way beyond our range, we used cloud to orchestrate, manage, and procure a lot of these devices that we're using in the end. This is enterprise, as well as home and personal residential stuff that we're using. Let's be honest too, it enabled DevSecOps methodologies. That's the whole idea about DevOps is being agile. We use the agility of cloud in order to make it so that we didn't have to submit tickets, to use servers, to write code, to build applications. We could just do it on demand. And I'll go to the far right. Just talking about the complexity that cloud has, the different services that we're using, the different platforms, the different machines. A zero trust approach is kind of one of those things that's a lot more necessary for us, right? We need an approach to secure this entire complex ecosystem that we know as cloud today. And if I want to go to the future a bit, or even to the present, quantum computing, I think it's a real threat because of cloud. The fact that we have so many data sets into one central environment, when quantum becomes a threat to data, our data's out there. Not to mention quantum computing availability, the fact that we have cloud resources at our fingertips. One day we'll have quantum computing capabilities at our fingertips too. So there's a connection here, and it all kind of highlights through this last one here, which is AI. Artificial intelligence, We've talked about it for a long time. It's not a new kid on the block, but I think what's happened over the last couple of years has really changed things. And so as security practitioners and professionals, we have to pay a lot more attention to it, just because it's not just a trend that we're following. Customers are using it, our staff, they're using it, and if your CEO wants to be competitive in business, he or she is presenting that to you now, telling us we have to do it, or they're just doing it just to keep up with the business, right? So this is a little, I like this little versioning number. This was presented to me by our CEO over at CSA, Jim Rivas. He looked at cloud as this evolving piece, and I kind of like this too. Cloud 1.0 was 15 years ago, where we like the bare metal, we like the servers that we're using. We're using kind of those bare minimums that we were using in AWS. As cloud evolved, we had these amazing cloud native capabilities. We had tons of analytics that come with that now too, right? We've seen cloud native application protection platforms. We're able to build containers in these cloud environments, and so wow, blew us away. We're able to do so many more things faster and better in cloud. Cloud 3.0 maybe promises the same thing. As AI is incorporated, as we see Azure and Microsoft co-pilotizing everything that they do, it's really bringing a brand new element to what cloud is. And these capabilities are something that, from a security professional, we're paying attention to, because is it different? Is it the same as it was in a cloud environment? We're finding there's a lot of overlap, and we've made a lot of efforts to identify what's the same and what's different, so we'll talk a little bit about that today. All right, to the present. These are similar headlines that I grabbed just within the past month about AI. And yes, AI, it really is just somebody's computer, right? We're just using someone's AI model, whether it's a ChatGPT engine or some sort of GPT to build applications. We're using someone else's AI model to do something with it. So yeah, why not the same thing? Break out those bumper stickers again. AI is just somebody else's computer. I'll have them for sale over here for $225 after this talk. I take Venmo. Another funny thing about this is, guess what I found just the other day? Yeah, could AI cure cancer? At least we're a little more pragmatic, not so definitive on it. But the same thing comes to mind. So when I go back 15 years, when we were moving all these health information systems into the cloud, the analytics today are exactly what we were looking for. I mean, really understanding correlations between patients' health, what their symptoms are, what their diseases are, into what we're trying to find with therapies. And not just that too, but with generative AI, we're not just creating our own guardrails, we're discovering new ones. And that's one thing I just wanted to kind of level set with everybody here. So what is AI to everybody in this room? And artificial intelligence is something we've been talking about for several years. And in general, it really is just a discipline. If we look at what machine learning and deep learning is, now that's a subfield of artificial intelligence, which is a little bit different. And that gets into the more specifics of what we're talking about today. So machine learning and deep learning, they use several different algorithms with data in order to maximize efficiencies and produce new capabilities, and we're seeing that today with generative AI. I'm going to go through two things just so we understand a little bit about what generative AI and why it's so different than what we're used to with AI in the past. So discriminative AI takes a classification of certain types of data. So if we're looking at data that we already have, data sets that we already have, we're defining how this is classified, and then we're getting algorithms and systems to identify new systems or new pieces of data that categorize into how kind of we've outlined this already. And generative has something a little bit different too, so it goes a little bit deeper into some of the deep learning algorithms, and if you're familiar, we won't go into like tree models or hashes or graph algorithms. But it goes deeper than that to understand, like, generates brand new sources of data. So we're not creating the guardrails anymore, it's defining new ones. And that's really the difference between generative AI. I think a lot of us are familiar with that. I like this example. We've seen a lot of images as cats, and so if you have photographs of cats in your data set, a discriminative model would be able to identify different pictures of what cats are. So if I put pictures of dogs in there and cats or watermelons, it can identify what a cat is. Now, if we look at a generative model today, what we're seeing with DALL-E, what we're seeing with Midjourney, These are actually going to generate brand new images based off of components of what a cat would be. So we have vector databases, we have pieces of what would be a nose, a tail, ears, body, and you generate brand new images, something that we've never seen before. So as a reminder, many people probably saw this picture going viral, several years ago, maybe a half a dozen, maybe 5 or 6 years ago. This is a picture where a chihuahua got mixed up with a blueberry muffin, and so you're able to trick AI. Everybody remembers that, right? Yeah, look very closely. Those aren't all chihuahuas. They're blueberry muffins and or chihuahuas. So that's an example of discriminative where you could actually trick AI systems into thinking something with something else. And today, with certain software, with certain capabilities, you can actually generate a brand new image of a chihuahua that you maybe have never seen before. So that's where generative and discriminative are different, and that's why I think as professionals, we're looking at things a lot differently now too, right? Because we're not just defining the parameters of threat intelligence, we're now finding brand new anomalies with generative AI systems. So that's what's really interesting about how we can use generative AI for security and why we need to think differently when we're securing it. Okay, and to be honest, I do like chihuahuas. I have one myself. And so everybody wants to see a picture of my chihuahua, I thought so, and so that's her right there. Some ahs and some tears are okay, because she's really cute. All right. So large language models are just that, right? They're these deep learning, they're pieces of deep learning that we use to generate text. At this point, we're using a multinodal to develop photographs, and we're already starting to use these things to detect network traffic anomalies and identify rules. We're using it to create reporting and things like that too. So these are the types of things that we're going to be using generative AI for in security, and we'll talk a little bit more about that a little bit later on too. But we'll get into some good stuff here now too. So cloud and AI are having babies. This is another thing that Jim Rivas taught me, and it's pretty simple to see. Anthropic and AWS making Claude. That's what we see today with Claude. We see Microsoft Azure and OpenAI producing ChatGPT. We see Google and DeepMind producing Gemini. And I think what's important about this, why I like the analogy, is because now that we're looking at these tools that our staff and our customers are using, like ChatGPT and Claude and Gemini, they have clear inherent characteristics of the cloud. And so that's the things we'll talk about. What's inherent from the cloud that is in these new models that we have to try to protect? At the same time, what's new from the other side? What does OpenAI, Anthropic, and these other models bring to the table that's going to be a little bit different? So these are generated from generative AI. And so interesting way to look at it, though. I like it because, again, generative AI is going to have the same inherent characteristics as cloud, and now some of these new AI models, and we'll have to look at those a little bit closely. So let's look at securing the cloud. I think these are common questions, so I'm going to just read these questions out loud, and I hope this resonates with everybody. What vulnerabilities exist in my cloud configuration? Where are my data and my processing being performed? Who has access to my data now? What does my cloud computing configuration look like? What auto events have occurred in my cloud configuration? I think these are things that we think about today, right? Funny thing about this too, these were actually brought to our attention in 2011 from one of my mentors, Ron Canode, who's not with us anymore. But 2011, he's saying these things. It's the exact same thing we're thinking about today. And so it makes me think about this. How does this reflect onto what generative AI is today? And that's kind of the stuff that we're going to look at. So when we thought about these questions for cloud, we had to look at the architectural patterns of what it is. And so for cloud, these should be very familiar. These are the characteristics of cloud. What makes it agile? There's resource pooling. There's on-demand capabilities. There's elasticity. And everybody's familiar with the service models, I hope. SaaS, platform and infrastructure, and how that works with shared responsibility. Raise your hand if you don't. Pizza as a service. That was a thing 15 years ago. I guess it's still a thing today. I just heard about it the other day again. And of course, there's public, private, hybrid, and community clouds. Another thing we looked at was regulation. So what regulation existed, and how do we overlay those into what's unique about the characteristics of cloud computing? So if you look at frameworks like PCI, ISO, SOX, COBIT, NIST, overlay those into what you see now as CSA produced the Cloud Controls Matrix. You've probably seen NIST produce FedRAMP, the FedRAMP requirements out of that. And so these are the things that you have to do when you're looking at new technologies. All right, we're gonna play a little bit Mad Libs. Who remembers Mad Libs, right? Simple game, right? It's a simple little story that you fill in the blank with nouns, adjectives, and verbs. If you don't know what those are, maybe you just know command prompts if you're a coder, but we're gonna go through these together. We're gonna play some Mad Libs together. That sound okay to you? All right. I'm gonna give you a hint. They're all nouns, and they can be interchanged with cloud or AI. Okay, so let's try the first one together. How AI can directly attack that impacts usage. Nice. Or how cloud can be directly attacked that impacts usage. Yes, that's how it works. Good job. How malicious actors can, will, and are using AI and or cloud. Cloud usage guidelines tied to existing security governance and frameworks. And we saw that on the last slide, and AI is going to be the exact same way. We will build the new tools and frameworks needed for cloud or AI's unique characteristics. We've seen that with the Cloud Controls Matrix. We've seen that with things like FedRAMP. Pretty much all the regulations have evolved to include not just cloud, but a lot of the SaaS characteristics that we're seeing today. And so we're going to have to do the same thing for AI. And I know it started already, but this early in the process, even though there's a lot of different regulations out there, we don't have a defined set of controls for AI yet. And so that's something that I know organizations are working on individually until we have a collective whole. Improving cybersecurity through appropriate use of cloud or AI, right? And so security as a service was a thing, over 10 years ago where we're deploying security services from the cloud for the first time, right? You didn't need software or a hardware firewall device in your environment anymore. You could actually do something through a cloud service. And of course, we need to anticipate any future changes that cloud or AI is going to present and set a roadmap in place for it. So we'll talk a little bit about that today, how we can get started, at least some resources that we can go to understand that. And we'll talk about how we did that with cloud too, right? So I think that's what's really interesting about this. I love inherited characteristics from cloud because ChatGPT is just a baby of cloud and AI. And how interchangeable a lot of these security aspects are. The same questions that we're asking from cloud 10 or so years ago, we're going to be asking that for AI today. History repeating itself. We're already talking about that a little bit. This layered cloud model that you see on the left-hand side of the screen, this is from 2009, and it's still relevant today because it really breaks this model down to SaaS, PaaS, and infrastructure. If we want to really set something up, we can say that there's a little bit more gray area between maybe where platform is and infrastructure, but these layers remain the same. There's the basic hardware components at the bottom where infrastructure is, up through the APIs in the middle layer into the presentation layers that we have for SaaS above there. And why history is repeating itself is because we're seeing the exact same thing with AI, with large language models being that fundamental layer down at the bottom, all the way up to where we're talking about the agentization of large language models going forward. So a lot of people maybe follow Andrew Ng, one of the fathers of AI, who's talked about this agents being where large language models like Claude, like ChatGPT, like Gemini, are actually being extracted and being tailored into retrained for a specific use case. So the whole idea was, is AI going to be this large sentient being that's going to know all and have answers to all, or are we going to create very unique, tailor-made LLMs that are going to be for specific use, specific for threat intelligence, specific for compliance, specific for making a cup of coffee. So very specific use cases, kind of like what we saw with SaaS and infrastructure services. So as we see things repeating themselves, we're seeing similar layers within the model itself. And I think when we see specific layers, now we have different layers that we can start securing. So securing generative AI and cloud could have similar aspects of it. The green layer right there, that's that middle platform as a service layer, which I feel like is getting kind of grayed out between infrastructure and SaaS. So yeah, good question. So if everybody can see the green layer between the SaaS and infrastructure, and where AI agents and LLMs are, what's going to be in the middle there? We'll find out. So all this, one of the big things I think that came on with cloud was the shared responsibility model. And so this is this is exactly what it looked like when cloud came about. So this was, Bruce Chen presented this, I want to say in 2009. And it's been adopted by all the major hyperscalers since then. But it has basic functions of a traditional IoT environment all the way from the infrastructure to software, so we can kind of understand shared responsibility from a customer and the customer tenant and the provider environment. And as we look to do the same thing with AI, Vishwas Manral got together with a bunch of people towards the end of last year, and we kind of discussed these 7 elements that are going to be kind of unique or different when it becomes to AI. So this is where things start to kind of identify different layers where we know access control is extremely important across cloud environments. And as we get into large language models, as we get into these agents, access becomes even more important, right? As we get into not just people accessing environments, but machines accessing other machine environments. I think we're seeing the growth of not just human identities, but the non-human identities, the machine identities are growing by the numbers with the amount of different services that we've had. I think the number that we've seen lately is for every human that you have in your organization, you have about 10 or 20x actual identities in there. So identity and access has a whole different component of it as we move into an AI environment. We thought IP and copyrights are a little bit different now too. And we saw that with some of the suits lately where depending on what your large language model is trained off of, is it trained off of IP? Is it trained off of copyrighted information? And so what it spits out at the other end, we don't necessarily know what that's going to be. Is that going to be protected as well? So you could say almost the same thing about privacy as well. Data control becomes a big challenge here too, because now we have not just large language model sets, but then we're gonna take a large language model that exists, one of the frontier models, and we're gonna customize that, train it ourselves, and tailor it to specific data, whether it's data I have in my own environment or data that I'm giving to customers. And so data control becomes a whole another aspect of that too, what goes in and what goes out. App quality, application interface is gonna be pretty similar, but now we're looking at different applications and how you interact with that data. And the tuning, going back to tuning, model quality, the infrastructure itself, this is all gonna be something very, very different if we start using large language models in this agentized way to produce new products or do different things with our own data. So that's the cloud model. We took those 7 aspects of it and it looked a little bit like this when we got through just a quick exercise. This is probably far from perfect, but when we had about 100 people get together to look at how the shared responsibility model would look like with AI, this was the first crack at it. It's available to view and download. It's also available to pick at and criticize because I don't think it's a perfect product yet. But as we're learning more about the technology, learning more about the capabilities and the understanding of it, we're trying to throw it into a new model so at least people can start getting a hold of it, right? If we're going to start using AI right away, do we want to embrace it? Do we want to block it? Either way, we need to know who's responsible for what, and this is an attempt at that. Okay, so A quick example of that too. So shared responsibility model, here's a kind of an example of what that would look like. So first example here is LLM data leakage versus traditional data security. So what does this look like in a large language model? You have employees, feeding a large language model. You're gonna have input, you're gonna have output, and I think we feel like the data leakage risk is still pretty low in this environment. This reminds us of just a cloud environment, right? The security of the cloud. If we put something in AWS, Azure, GCP, Oracle, I think we feel like it's pretty secure. Now, don't get me wrong, we understand misconfigurations happen. A lot of this is on the human error side of things, but we feel like this kind of environment is, the data risk is a little bit lower. As we move into these agents, this SaaS layer of how SaaS is going to deploy new large language models, new custom large language models. Some people are calling them small language models, but I think they're still large because they're based off of those, foundational frontier models. But now you're looking at the whole orchestration of training and tuning new data, creating new agents and how those are deployed, and creating new sets of data sets, vector databases that you need to protect. So when we start building our own LLMs and building our own AI agents, we see this is where data leakage becomes a lot more real. And the important things of what we talked about, access control, understanding identities is going to become a much bigger issue here. And this would be that cloud model with AI when we're looking at what's that AI application interface layer look like, how do agents work within orchestration, all the way down to the data that it's extracting from the large language model. So this becomes probably like a more real security scenario where what are we doing to protect large language model agents that are going to be deployed through SaaS marketplace. So something a little bit different there. Okay, so when we think about AI security and safety, other considerations that we looked at when we explored some of these things, we wanted to look at near-term issues. I think that's pretty important to not just think about what to expect down the road, but what do we really need to think about now as we're using these things and maybe even deploying LLMs in our own environment. So, okay, maybe we think some of the querying from LLMs has got a pretty low probability. It's a little bit overhyped on what that looks like. But the same data lifecycle and data governance issue still exists. So this is something that's going to be inherent from cloud, to where the same kind of lifecycle that we're using to protect the cloud, the same data security practices should work here. Prompt injections become a little bit different now too, because now prompting is how you interact with the data itself. And I think we've already seen abilities from prompting to trick AI into doing different things than maybe it was meant to do. And that can lead into just some of the deep fakes and the hallucinations and the biases that come into play too. The prompt injections, I think we're looking at different kind of outcomes that come into play there too. So I know when we've just kind of talked to other people, where one thing that prompting is really good at right now too, it's good at if you create scenarios, if you actually create a persona, you ask it to do something. And so if, for example, I think this is an older case, but when ChatGPT first came out, it could create phishing emails for you. And then they put up guardrails so it couldn't generate phishing emails anymore. But you could put yourself in a persona where, hey, I'm a CEO, I'm red teaming my team, and so I need to create some phishing emails for my red teamers to see if they can fix them. Now you're able to get the LM to actually generate stuff for you. So prompting becomes a pretty big deal. Data poisoning, I think that was part of model evasion, but data poisoning is something where you can also inject, if you don't have an inference model, you can actually inject prompting into how the large language model produces outcomes. Hallucinations and deepfakes and biases. I know these are things that we've seen already too before, right? One of the biases I thought that were pretty funny were, I know we're trying to make LLMs be not biased, but then it also impacts some of the accuracy. So there was some prompting about creating World War II German soldiers, and it would create a very diverse group of German soldiers, which was kind of nice to include, but at the same time, it wasn't super accurate, right? Because we didn't have a lot of, Asian women, for example, in the German armories back in the 40s. And so these are the things that they'll be working on improving, and they continue to improve things like that too. Hallucinations, I think they're still a thing, but at the same time, we're using RAG, which is that retrieval augmented generation, where you're actually validating things on the internet or validating things from another large language model. I think that's really important to do as well. And AI-enabled malicious attackers. I think that's a big thing. How are attackers going to be using AI to be a lot more efficient, to generate better phishing attacks, to be faster at recovering from attacks? And that's going to be the thing that we're going to be worried about the most too, is not only are we using large language models and generative AI to improve our posture, to improve how we defend against things, but we tend to have enterprise policies around blocking and the usage of. Adversaries don't, so they tend to move a lot faster than we do. And that last one I think is really important too. Identities and privileges are going to be super important even now, just because they're already happening at an exponential rate. This is a report. This came from a couple reports that CSA did. One at the bottom is recent, and this older one's at the top. But again, one of those comparisons between cloud and generative AI. When cloud was first started deploying security services, I think we remember the term security as a service was pretty big. Now it's just another SaaS tool. But these were the top 10 security as a service deployments that people used in 2011. That organizations were building and developing for products. And in 2024, these are the top use cases for generative AI, anywhere from network rule creation. We have attack simulation and red teaming, code analysis at the bottom for sure, event log summarization. If you checked out the Innovation Sandbox, there was an organization that was actually doing a lot of the log summarization, so replacing some of those entry-level SOC analysts, where it would do the report generating for you. So if an event comes in, it would generate everything from SOC to your CISOs to your legal teams and eliminate that whole aspect for you too. So we're seeing a lot of pretty interesting cases for security already. Okay, some of the long-term things, I think, at the rate things are going, maybe some of these are a little more near-term than we think of. But there's certainly a lot of huge investments in LLMs today. Every time you look, there's larger token sizes, there's increased parameter sizes. The growth in just compute, I think, is there, which makes these large language models the ability to host larger ones, to process things faster. And the result is certainly brand new capabilities that we haven't even thought of yet. So I think these are some of the things that become really interesting, because since we're not putting any guardrails around some of these large language models, the end result are things that we don't quite understand yet. I've always thought of this too. Whenever, everybody's familiar with artificial general intelligence, when AI basically meets or surpasses regular human intelligence. I always think it's an interesting, when will we achieve AGI? And to me, I don't think we'll recognize it when it happens, because it's going to exceed general human intelligence. So it's one of those things where artificial intelligence systems are going to start coming up with responses and results that we didn't think about, and we can't even understand how they got there. So it's going to be interesting when AGI emerges, or when you look at some of these new capabilities that come out of AI models. How can we interpret those? That's going to be an interesting thing to me. Like, will we argue that it's a hallucination, not a real thing, and how we'll be able to determine if it is or if it isn't. So a lot of this stuff I think is interesting. Again, exponential growth in identities, that's a given. Frontier AI models versus frontier AI models. We saw this in the beginning of cloud, where there was a big battle between cloud infrastructure service providers, what we're calling the hyperscalers today. There was a big three that ended up coming into play. There's certainly more than that. There's a handful more than that, but there were a big three that emerged. AI, we're seeing the same thing where there are 3 frontier models right now that exist. But I know if you think of what Meta's doing with their large language model, Llama, and who knows what's happening around the rest of the world, yeah, how many more frontier models are going to emerge? Right now, if you go on Hugging Face, there's people who like to play with their own large language models. On Hugging Face, you can actually download today 160 different large language models. And so you can create a private large language model like on your desktop or on your own servers and run that yourself. And Meta Llama is also available on Hugging Face, open source, and it has, I think, 1 trillion different parameters on there. So it's incredible what you can do with these things. All right. I think it's good to just summarize things and have some actions, because I think there's some cool stuff that is happening in the industry, and I want to summarize kind of the stuff that, some of these inherent characteristics that we talked about, but also what are some actions and references that we have, because there's a lot of good tooling that's out there. There's a group, there's an initiative at CSA that's done a great job of collecting all these resources, so I wanted to share that with everybody today. And a lot of this stuff is brand new. It either just came out this week or it'll be coming out next week. And these links will still, they still work. You might not get the actual source until next week, but I wanted to cover a few different topics. So AI technologies and risks. I think this is so fundamental. Before we protect something, before we secure something, we need to understand it, which means we need to play with it. We need to play with all these different technologies, all these different large language models. We need to understand what customers are using it for, what our staff is using it for, and how that enhances the business. Isn't that what we're asked to do as security practitioners? How are we helping grow the business? So important to stay up on these technologies and risks. There are 3 references that I think are really cool to look at. There's a large language model threat taxonomy. So this gives common language definitions and a taxonomy for AI risk scenarios, for threats, for vulnerabilities. It just came out of a worldwide peer review where we had over 2,000 people comment and respond to and react to it, or not react to it, but actually engage with it. That'll be released next week. The second thing at the bottom here too is live now already. So there's a collection of over 400 different threats that are specific to AI that map to common vulnerabilities, and you can actually look at that now. There's over 400 and counting right now that you can actually just check out, see if that's a real threat in your environment. And it's always one of those things, right? I think it's funny when someone else tells me if something's high risk or not, because I need to understand if that impacts my environment. And so with this list, there's not necessarily an impact rating, so there's a lot of threats to look at, but you can actually go through there, correlate it to maybe some other common vulnerabilities that you're looking at, and see how that impacts your environment. So a tool that's available, that's only been available for less than 2 weeks, so that's something that's kind of cool and available now. And we just made it it's just a growing list. So that list will always just continue to grow as they add more to the 459, I think that's where they're at right now. There's also an AI risk model framework that just came out actually a couple days ago from a publication. And it's a risk management model similar to what NIST did, but it goes further into the deployment, development, and use of generative AI. So it does just build off of the AI risk management framework that NIST has and provides a little more context and detail for use. Once we understand the technologies, we also need to understand the governance and compliance aspects of it. It couldn't be more important than that too, and I think a goal that not just we have as a country, but as organizations, we're trying to establish any type of standards for artificial intelligence. We have another link here too that just went live about a week and a half ago. This has over 200 references for governance and compliance worldwide. So this captures different frameworks from the EU AI Act to acts in China, different states within the United States and across Europe, as well as just other references on understanding governance for AI in your organization. So there's some companies that have put that together too, like IBM, Microsoft, and AWS. So those are captured there too. But over 200 references that are easily available for you there. as well as a new benchmarking model for AI safety. So this is a holistic approach for understanding what kind of controls are going to come into place when you're building out an AI strategy. This is also available now. It was just released Monday at the CSA AI Security Summit. So as we keep rolling there too, we understand the technology, we understand the regulations, and we understand some compliance efforts. Now we can actually start building organizational responsibilities on AI within your company. This is an initiative that's going on as well, with the goal of not just understanding who's responsible for AI within your company, but how to deploy and use AI within your organization. So a couple good references here. Core security responsibilities. This gets to those inherent characteristics that we see in cloud and things that are going to be generated that's going to be new within the AI. There's also a survey of over 3,000 security practitioners on what the state of AI and security is. And one of the coolest things I think that came out of there was that top use cases for Gen AI and cybersecurity. So there's actually, if you dig into that report, there'll be a link that actually bakes out what those 20 are. So not only do people say these are the 20, but we actually have another, there's additional guidance on there that shows you, explains what each one is and how you would deploy that in your environment. And I think one of the last ones here, we kind of touched on it a little bit too, but safety and security controls. So can we define a framework that's specific? Can we look at the existing frameworks that we have, whether it's just standard infrastructure and IT environments, whether it's security business risks, or whether it's cloud computing? What are those inherent characteristics that we're going to have and controls that we're going to actually define for AI? There's nothing on that yet. Here's some goals and things to consider as we meet with a lot of organizations. I've certainly met with some organizations that have a pretty strict no-use policy on generative AI, but they're starting to lift those as they define kind of just, how would we manage those things in our environment? And so these are some of the common core functions that are pulled from things like the Cloud Controls Matrix, ISO 27000, the CIS security benchmarks, and you can kind of see how that would work in these 4 bullet points here. So hopefully more to come there. That's one of the biggest, I think, challenges that we have is actually creating net new controls for AI, and just because those type of frameworks are so well, they're going to govern organizations and lead the standards bodies. So I think that's next in line. Certainly a goal for organizations to have. Here's a good reference sheet too. So all these slides are available to download, once you leave RSA, or even immediately right now if you look online. And these links are all here for you. So there's the whole AI safety initiative that I think is really important, that captures, at CSA, that captures a lot of different activities that they're doing, from technology and risk, education, governance. The Stanford Helm model is great for testing and evaluating AI systems. So Scale AI uses a version of that when they're testing AI systems for the federal government. Responsible AI, Hacker Noon, the EU AI Act. There's actually ChatGPT security implications that CSA put together. There's the OECD put a classification of AI systems together. NIST has several drafts on AI biases and risk management. And OWASP has a top 10 for LLMs already, so they were the first ones to do that. Very worth looking at, and I know it's a stepping stone for a lot of organizations on building controls and mapping those to existing controls that they have. So that's your first step, probably, into generating security controls for AI. All right, this is kind of it. When you talk to a lot of different organizations about their approaches to AI, and as we work through it within even our own organization, these are like the top things that we really looked at, where we need to assess the business approach for AI and cloud within your organization. So we're only going to go as far as what our organization wants to do. So are we aligned with the business or not when it comes to the use of generative AI and the use of cloud? Super important that your security teams and any business teams have literacy on the AI piece. This is both from a security perspective, but also on the use of. So if we look at security and privacy, do we understand how those foundational models work? Do we understand how prompting works? Are we able to track the regulations and the laws that are out there already? Can we establish some of the security controls and benchmarks? And can we apply those to our teams and the team roles? And so with that, I know there's a couple minutes left, and Armstrong says we have 5 minutes left. And so there are 2 microphones there. Everyone's allowed to come up there, ask questions, and I think that's it. Oh, there we go. I gotta show my pictures of my dog and my muffin. All right, there we go. So any questions up there? Yeah.
Thank you very much for
Yeah.
the presentation. Lots of insightful links in there as well. My question was about the slide where you were showing that the data leakage risk might be low if people are just using GPT. So I wanted to understand why you think that is the case, because if people are just publicly using GPT, it
Yeah.
does get trained on that, right? And you can have a vulnerability a year from now in GPT that actually leaks the data.
Yeah.
And then we also have some other questions that were raised in like the crypto panel in the morning about GDPR and how do you actually go and delete data, things that you
Yeah.
could do in the cloud, but you may not be able to do once the model is trained on the data as well. So
Yeah.
that was one clarification that I needed.
Let me start with your last question too, because you talked about GDPR and privacy, and you're right, privacy is easy to go back into a cloud environment and fix things. We certainly talk about security by design. It's easier to do it if you have that built in. And large language models are a lot harder, for sure. To train out information, we found it to be extremely expensive and very GPU intensive. Referring to why we think data leakage is going to be low there is because most of those large language models are hosted in cloud environments. So if I just take ChatGPT, since you mentioned that, it's hosted in Azure, and those models that they give to the public are inference models, which means that when you interact with ChatGPT, when you're asking it questions, that doesn't go into the training model itself. So the only part of that actually is going to have data leakage is that interface between you and the OpenAI, the ChatGPT, or the Azure environment. So we feel like that's very similar to what we're doing right now with infrastructure as cloud services. Not to say that it's completely eliminated, but we kind of understand that a little better with some of the configuration management that we're doing now. So that's why that was considered a little bit lower.
Okay.
Yeah, but not eliminated completely, for sure. Yeah.
Hi.
Hi.
Thanks, John.
Yeah.
So a small question or your thoughts on this. In most cloud environments now we have an incident response plan, right? How to manage process procedures, controls, and communications. Do you see the incident response plan changing for when corporations move to generative AI and using those in AI environment?
Yeah, that's a good question. Where I see it changing the most is being able to utilize generative AI for response. I think we can be actually a lot faster when it comes to responding to things because we're gonna, the threat intelligence we're gonna get is gonna be a lot more efficient. Not only that, but our response is gonna be auto-generated and automated a lot more. With that, yeah, if we're talking about incident response from that perspective, I think that's where we're gonna see it change a bit. But yeah, still a lot to learn for sure.
So I do have another question.
Hey.
The slide where you were showing security use cases for AI, there
Yeah.
was anomaly detection there.
Maybe I can jump there real quick. Oh, no, I can't. I think I can recite it for you if I don't remember it. Oh, there we go.
Yeah, there's an anomaly detection in the bottom half.
Yeah.
So isn't that a use case for discriminative AI? It's just a classification problem. So
Yeah,
if
yeah.
we have not been able to solve it in like 10 years,
Yeah.
is the inherent issue more with the data and we are just hoping that generative AI will solve that, or
Yeah.
is something generative AI can do that it cannot, that discriminative could not do?
Yeah, no, I mean, it's it's a good point. Do we expect it to solve things right away? You know, probably not. But can it do more than discriminative? I think absolutely, because discriminative, we're giving it an outcome, and we're telling it to tell us it's one of these 10 things. But with generative AI, it's going to tell us that it could be something else that isn't in our line of sight yet. So I think that's where the advantages are when it comes to anomaly detection in generative AI.
So it can tell us what our analysts could not find.
Yeah, it's it will generate new outcomes depending on how good the data is. But yeah, that's the intent.
Okay, thank you.
Yeah.
I just want to say that it's a great presentation.
Oh,
Wonderful.
thank you very much. Oh, thanks so much, everybody. And I think we're out of time, so appreciate it, everybody. Thanks, Armstrong.